the needs for complex software are there. So it doesn't really matter that much whether we want it or no. We are forced into it in a way, right?
This is DevOps Paradox, episode number 282, How to Measure Software Complexity. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darin and Viktor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darin reading this text and feeling embarrassed that Viktor made me do it. Here are your hosts, Darin Pope and Viktor Farsic. Viktor, have you ever heard of John Gall?
No idea.
No idea.
I heard of Father John, but not the Gall.
Not the Gall one. Well, John Gall, looking at his Wikipedia page, passed away in 2014. He was born in 1925. So he was a little before both our times, but he hung out until 10 years ago. He was known for his 1975 book, General Systematics, an essay on how systems work and especially how they fail. We don't know anything about failure of systems, do we?
No, my systems never failed. And I'm now planning to also start writing code in Rust because Rust has no bugs, I was told.
Has no bugs.
No bugs.
It's a bug-free language.
Yeah, when you write code in Rust, you're bug-free. That's the promise.
Interesting. I think that's going to be a different episode. We'll see how that plays out. But Gall's law states, and I'm going to read this, a complex system that works. Okay, a complex system that works. Do we need any more than those 5 words? Because in order to get to a complex system that works, here's the definition, is invariably found to have evolved from a simple system that worked. Continuing, a complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working, simple system.
That sounds like the first thing that comes to my mind when you read that is cities. Right? Cities would probably fall into that category. It's a complex system that works. It wasn't designed initially with the scope it is today. It just evolved there.
It's sort of like the sidewalks on a college campus.
Yeah, that's designed.
Well, except for the college students don't stay on the sidewalks. They just cut across to find the new sidewalks. So that's what I'm saying is you did this whole big grid of sidewalks that nobody uses instead of first waiting to see what the traffic patterns are and then laying down the concrete.
Exactly. This inevitably will lead towards waterfall, this conversation.
I think we're already there, but let's put it into something a little more concrete. So let's apply our text base to the first 5 words, a complex system that works. Can we define a complex system right now, just for definition? Let's say it's Kubernetes. Right? Is that fair enough?
Yeah, that's a complex system, fairly complex system.
Right. Is invariably found to have evolved from a simple system that worked. What would have been the simple system that Kubernetes would have evolved from, or maybe multiple systems?
In the first iteration of Kubernetes was only stateless applications and only Docker, without much more. Basically, it's how can we run containers? And a bit of networking, very primitive one. Right, so it's very, very different from Kubernetes today. Especially if you count into Kubernetes not only Kubernetes itself, but what the end result. The end result is almost never core Kubernetes only.
So you're saying the simple system that got to initial Kubernetes, right? Let's make that part. Was
relatively
Docker.
Speaking, simple. Yes, was a way how to schedule Docker containers across a fleet of nodes. I'm simplifying it now, but let's say for the sake of argument, that's what it was.
So how did we get to that point? So we're stopping at V1 of Kubernetes, not V1 technically, but the initial versions of Kubernetes. Docker led to that, but what led to Docker?
What led to Docker is a company which name I forgot now, the one that Solomon had before founding Docker, trying to solve its internal problems for the SaaS services that they were offering.
Okay, but what was the technology that got us to that?
Technology is like ancient. We're talking about namespaces and stuff, the things that nobody knew how to use but existed in Linux forever. Is that what you're referring to?
That's where LXC and the other types of containerized, even though it wasn't containers as we know it in 2024.
By the way, containers as a term still doesn't exist in Linux to this day.
No. I was just referencing it as a container. It's not a container. Yes, I know. C groups, everything else, right? Because Docker gave us the ability to manage C groups easily.
Exactly. It made it available to the masses, to everybody. And when I say everybody, literally everybody can learn it in no time.
Now, we're not going to continue on from prior to C groups because that really predates. Well, it doesn't really predate me, but it's part to where I didn't get into it.
Yeah, we're not going to go down the route of mainframes and whatever was before Linux, right? Unix. Let's talk about Unix.
Now let's imagine a world where Kubernetes was just trying to be created by, let's say it's Google, because Google created Kubernetes for Magic Handwave. And they just said, here's Kubernetes. Could they have done that without prior things? Going back to Gall's law, a complex system can't just exist. It has to be simple systems first prior to getting to the complex.
So, I mean, in all fairness, they could have done it, whether it would be successful or not, without Docker, but they couldn't have done it without, C groups and what's not, or at least not in nowhere near the form that we have it today, right? It's very hard to play could have, should have type of game, right? So yeah, they couldn't have done it without prior work, of course. That applies to almost everything, right? On the other hand, it was almost inevitable that some kind of system that would allow us to leverage compute at large scale would appear sooner or later. But yeah, they would need to come up with proprietary stuff if it didn't exist. And that would still be based on prior work.
So we've talked about Gall's law a little bit, but I want to focus on a blog post by, and please forgive me, I'm going to try my best, Mahesh Balakrishnan. Mahesh, if I got it even close, it's a miracle. And if I butchered it, I apologize. But he recently had a post from May of 2024 titled The 3 Laws of Software Complexity, subtitled, or Why Software Engineers Are Always Grumpy. So do we really want complex software, Victor? Do we want it?
The needs for complex software are there. So it doesn't really matter that much whether we want it or no. We are forced into it in a way, right? Because, if you go back 20 years in time, then making something that can sustain any number of users would be very different, because any number of users would be, if you ever get 1,000 concurrent users, that would be unbelievable. We're never going to get to that number, right? And today that's the hobby site. That's kind of, okay, this is ridiculous. Of course, that's the requirement to run on your laptop, right? Requirements are changing through forces around us. And with those changed requirements, complexity is increasing as well. Now, the question is, how much of that complexity do we see and how much we don't, right? Because you can say, hey, I set up and run Kubernetes myself. That's much more complex than I use GKE, which is more complex than I use GKE Autopilot, which is more complex than I use Google Cloud Run. Now, realistically, there is no difference in complexity. I mean, there is some difference, right? But for the sake of argument, all those systems I just named are equally complex, but we as users do not necessarily see that complexity. But it's there.
So let's get into the 3 laws that Mahesh wrote. The first law of software complexity, you may laugh, you may not laugh. We'll see. A well-designed system will degrade into a badly designed system over time. Is this foreshadowing for Kubernetes?
Yeah. I mean, I'm not sure about foreshadowing Kubernetes, but what he's saying is inevitably true for 2 major reasons. First, because we mess it up over time, right? You have a greatly designed system, and then, the more people work on it, the more of a mess accumulates. That's just how we humans operate, right? I'm yet to see many examples of companies who actually spend significant amount of time cleaning up the mess. That's rarely happening because, hey, it's working. And the other reason is what I mentioned before. The requirements are going to change. And when looking at the system a while later through the prism of new requirements, we say, hey, this is just silly. This doesn't make sense. This is so badly designed. But it's not necessarily, I'm excluding now the case of people messing it up over time, right? It's not necessarily badly designed according to the requirements when it was designed, but with the introduction of new requirements, that turns up into a bad design. If I need to have 1 million concurrent users, this is just horrible. I would never design something like that. But when it was designed, that was not a requirement. Did they confuse everybody now, right? I'm not sure even what I said.
Well, what you're saying is we had the initial requirements. Everything was met. Then we start doing change requests against that system. And we lose the plot of what that initial system was meant to do. We start turning it into Frankenstein's monster.
Bingo. That's the point. And when I say change requirements, I don't mean only, hey, the management is willy-nilly every second day changing things, but simply what we need is different every month, every year, right? The needs are different. You cannot compare, I don't know, let's say Netflix today with Netflix, 10 years ago, right? Their system, the requirements are very, very different today from back then.
So if you believe you're going to write a system and launch it and never touch it again, it's possible. But I think in this decade, that's not going to be probable over time.
To be clear, that's happening with almost anything. It's not related only to software, right? I can say the same thing for, bridges, right? If you take a bridge that was designed 100 years ago, it was designed with the idea that, hey, you might have on average 1 car every 5 minutes. And now you have, 1 car every 5 seconds, right? The load on that bridge must be different. And it's not necessarily going to collapse right away, but it's going to get wasted faster than originally thought.
How can we handle these change orders that come in on a system? Should we reject change orders if it's going to change the system too much?
Of course, you can reject some change orders, but more often than not, you cannot change because what we do is for the benefit of business that we work for, right? So I'm now excluding silly requests from silly managers who don't know what they're doing. But in general, you cannot change requests. Hey, we have more customers. That's a new request. You need to handle a higher load. I cannot reject that. I cannot say, hey, you know what? We can go under. We can go bankrupt. Why do I care, right? I mean, you can try to do that, but that's not how the world works. So you have new requirements and you need to accept them. There are actually 2 important questions there. Will you do what is necessary to prolong life of something? And this can be equally applied to software engineering or anything else, right? So I can have a system that is designed like this, and it will survive 5 years. We don't know that in advance, but history will tell us later that it's 5 years, right? Now, there are certain things I can do to that system, modernize it up to a point so that it survives 10 years. As long as we understand that that's investment that needs to be made. And another second thing is to recognize when does the maintenance of that something, the price of maintaining that something and applying new requirements end up being higher than replacing it altogether. And I could repeat exactly the same story for the bridge example before, right? You're maintaining the bridge, but then comes the time and you're prolonging its life by painting it, increasing the structural something. But then comes the time that you say, you know what? This is so expensive now for this bridge that I'm going to create a new one. It's going to be cheaper and more efficient for me.
I'm a simple person. I'm going to use a car example. At a certain point, a car becomes too expensive to maintain.
Exactly.
Then it's just time to go take another $5,000 and go buy another cheap car that's going to last. Toyota or a Lexus or Nissan or Infiniti, by the way. I love my European cars, but they're too expensive to maintain. The others, not so much, in comparison, at least. So at that point, once you maintain that vehicle, and now you're spending $600 a month, but that $600 a month be better towards a new car.
Yeah, and that new car might be cheaper than the original price of the old car that you bought, and you're still going to get better value. Because things change. I don't know. Now it's electric, or now has auto brakes, or whatever. I don't drive car much, but whatever new things are, right? You're gonna get it and most likely, yeah, you buy maybe not 5,000, but if it's a new car, 15K car today, and that car is going to be cheaper to maintain than your old car, and give you more benefits than that old car that you maybe paid 50K.
The tech analogy, once it starts costing more, it's time to get rid of it.
Yeah. But now we're coming to the problem. If I keep the analogy with the car, you said, I don't know, $600 a month to maintain, right? And let's say for the quarter that would be 1,800, right? And you say, okay, but you know what? If I invest 1,800, that's still much cheaper than 5,000. And we just need to push through this quarter. We just need to survive it now, right? We'll think about the new car later. And then it flows from one quarter to another, and your cost of maintenance is going to keep increasing, right? But surviving short term is almost always cheaper than longer term investment. And that cheaper on long run is more expensive, just to be clear, right? But right now, the amount of cash I need to put into fixing that old car is smaller than buying a new car.
Because you're trying to buy the new car cash, or at least near cash.
Yeah, let's say like that, right? Kind of, that's the investment I need to make. So then you say, so what should I do? If I'm focused on my well-being, my future, it's quite clear what I should do. I should find those 5K, 15K, whatever the price is, and buy a car. It's very clear. But if I'm thinking on the short-term benefit for me, if I'm only focused, if nothing exists beyond this quarter, the world will end, then repairing the car makes more sense. And I feel that many companies are more focused on the latter case. Don't give me that 5 years, whatever. There is the quarter, and we need to be successful in it. And that's why we have old systems that are extremely expensive to maintain. And everybody or most people know that it's silly that it's not replaced by something. It already passed the threshold of I can improve this, right? No, there is no improvement to this system. It costs hell of a money, And we all know that we should go with something else, yet there is no will to do it.
Let's move on to the second point. The second law of software complexity is a moat filled by leaky abstractions. Let me read the first sentence. Designing a good abstraction is a delicate dance between providing utility to the application while hiding detail about the implementation. True, right?
Mm-hmm.
We need to do that. The problem is, I'm trying to find it here real fast. I'll just jump to the bottom of the paragraph. Based on this law, most engineers will work on badly designed systems because most successful popular systems are badly designed systems.
I don't agree with the last part of badly designed systems. In retrospective, yes. Oh, if I would have the experience, if we would have experience we have today with Kubernetes and applied it with whatever we were doing 10 years ago or 20 years ago, it's so clear that 20 years ago was a disastrous system, right? But you cannot apply that logic because we did not know what we now, or back then what we know now. I must assume that at least some of the companies or projects are basing their APIs and systems and abstractions on the prior experience. I'm not saying that everybody is doing that, but right, we are better at designing things today than we were in the past. If you know that this is badly designed system, then be my guest. Let's talk about whatever is the name of that person, what's bad about it, and we can improve it, right? Whichever system we're talking about.
The example that he's giving here is, in fact, I'm just going to read the whole system or the whole paragraph. When systems compete with each other for market share, delicacy goes out the window and designers often give the application everything at once. That goes back to that first point, right? We keep dumping things in. This has a dual effect of increasing market share by attracting developers while simultaneously making it difficult for competing systems to substitute different implementations under the hood. The example he gives is the way Zookeeper and Kafka does things. And it's like once you marry yourself into that system, it's not like you can just go swap out Zookeeper for something else without a lot of work.
Yeah, it's absolutely true. But then this is going back to the analogy of the car, right? There are many decisions in Kafka that do not make sense today. That is not to say that they didn't make sense back in the day when Kafka was designed. I mean, I remember those days. If you ask me back then, what would I use? Zookeeper. Oh, Zookeeper rules. Of course I'm going to use Zookeeper. Now if you tell me Zookeeper, I walk away. I don't want to be in that conversation even, right? Now, the problem is for that person is, okay, so are you saying that Kafka system that you're using right now is equivalent of the old car and you're not willing to buy a new? It's going to cost. Sure. But maybe the total cost is not going to be... the total cost might be paid off in a year or two, which is not such a long time. I'm not saying that everybody should replace Kafka, just to be 100% clear, right? I'm just saying that you need to do that cost-benefit evaluation all the time.
And not just once at budgeting time.
Maybe it should be a quarterly exercise. Okay, we know that we have ton of stuff that we shouldn't have. What's the pick for this quarter to replace? Make a pick. There are plenty of candidates in every company. It's not only one. There are many. So pick which one in this quarter should go out, or not out, be replaced.
Well, I've been seeing that a lot in companies to where they are trying to get more efficient in managing cash. So that means getting rid of subscriptions. Heck, I can even apply that to myself. What subscriptions can I get rid of at the house? Netflix stays. Does other ones go away? Because do I need them?
Yeah, exactly. They accumulated, at least in my house, they accumulated over time. And Actually, it was maybe a month or two ago where I looked and kind of, okay, man, this makes no sense. I mean, I can afford it, but it makes zero sense that I have HBO Prime, Disney, I have Netflix, I have Apple, and probably 7 others that I haven't used in kind of 2 years. And yeah, I had to get rid of some of them. Now, this is slightly easier than what we are talking about because, getting rid of subscription that you don't use or doesn't provide much value is an easy exercise. Removing Kafka is not about removing Kafka, it's about finding a replacement and changing a bunch of things. It costs a lot. But the question is, should it be done?
And the third and final law of software complexity, there is no fundamental upper limit on software complexity. I'm going to read the first sentence. I don't think I'm going to have to read anything else beyond this. In real-world systems that are built by large groups of people over time, complexity is limited only by human creativity.
As long as that assumes that when we're talking about complexity, we're talking about something that accumulates over time, right? Not by designed complexity, right? Most of the time it's not designed complexity. It just becomes complex over time. That's how anything works. You are getting a new house right now, right? And when you move into that house, man is going to be less complex than half a year later. When you put all the furniture and forget to clean the rooms and what's not, right? It's inevitable. That's how life works.
I think you said it went backwards. Did you say it was going to get less complex over time? I don't know about
did
that.
I say less? No, I wanted to say more complex. Yeah, exactly.
Yeah, it gets more complex.
Yeah. Is it badly designed house? No. Was it complex house? No. The act of moving in and living in it is going to increase its complexity. Guaranteed.
The part I liked about his sentence, though, is complexity is limited only by human creativity. I think he was being polite. I'm thinking about new people coming to work on an application that have never worked on the application before. Maybe this is their first application ever maintaining. And they're the only 10th, 15th, 20th tranche of people to come through and maintain this application. People will get creative over time. I mean, we'll use your 20-year. We'll go back to 2004. What were you writing in 2004, primarily?
I'm ashamed of whatever I was doing in 20 years ago.
Okay. But there are applications that are still running from 20 years ago.
Yeah, of course.
And what are the chances that the people that were working on it in 2004 are the same people that are working on it in 2024?
Very few, right? Kind of, we retire eventually. We move to other companies and stuff like that. But again, that shouldn't be a problem, right? The problem that we see in that example, at least from my perspective, is that means that your senior people are not doing their job. I cannot blame juniors for being overly too enthusiastic, right, and wanting stuff. I mean, you want people like that. You want people who are excited about the things they're working on, that they're motivated, and they go there and they mess it up. But then it's you have zillion years of experience, it's your job to guide people, right? And it would be the same thing as going back to the bridge example. You don't put random people to do random stuff in constructing a bridge. You have somebody who is overseeing it, and that somebody is probably more senior and knows what he or she is doing and what's not. A good example is, I don't know exact date, but it wasn't that long ago that there was a single pull request in Kubernetes that removed around 1 million lines of code. Do you understand what is 1 million of lines? That number by itself is bigger than many people's systems. Maybe not systems, but applications or platforms or whatever it is. Kubernetes community removed around 1 million of lines. That was code that was related to cloud providers, AWSs of the world, and it's all removed, and the complexity was reduced. It's possible, but it's work that nobody wants to do. I mean, not nobody, but not many.
I wish I would have been an approver on that one. LGTM, million lines gone.
I would approve it without going through it.
You wouldn't even done that. You just said, yeah,
just go for it. Go for it. I trust you.
Once you have that level of delete, you had better trust whoever put that PR in.
It's been a long time going, so it's not that example is not something that happened overnight. Those same providers are working on how to provide same functionalities, services outside of Kubernetes as add-ons and what's not. So it was a process, but it ended up, it's a process that took time, it took effort, money, everything, and it resulted in approximately 1 million lines of code removed. It's an conscious investment, and I'm very impressed by that, something like that.
So how do you measure your software complexity? Head over to the Slack workspace, look for episode number 282, and leave your comments there.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.